Alright, so here's Lois Lane, here's Superman, okay, and it's Superman is 120 meters away from Lois. The rock that is falling is 4 meters away from Lois. So I chose this equation because we know what x is going to be. It's going to be either 4 or 120. I'll discuss that later. We know what the initial velocity is going to be, and we know what acceleration is going to be. That's going to be 9.8 because dealing with the rock, when dealing with the rock, it's going to be 9.8 because the only force acting on the rock is gravity, and it's constant. So that's why we're using 9.8. And so the only thing I don't know here is time. So that's why I'm using this equation. Initial velocity is going to be 0, so this part is just, we can cancel this out since everything here, it wouldn't matter, it's just going to be 0 anyway. So this is the modified equation, and I'm isolating time. I'm going to have to square time to get the answer. Okay, so for the rock, okay, and meters cancel out, 0.904 seconds. Okay, so that's how long it's going to take the rock to hit Lois. Okay, so now we need this in order to find Superman's constant acceleration, because we don't know what Superman's constant acceleration is. So now I just took the modified equation. Okay, the initial velocity is still 0, so we use this, but now I'm going to isolate acceleration. And since we're solving for Superman, we're going to use 120 now. Okay, and the seconds for the rock. And part A is this. Now for B, since we know the acceleration and the time, we can go ahead and find the velocity, and it's as simple as just plugging it in and multiplying straight across like that. So this is how, well, this is the velocity of Superman.